Well, welcome to Unit 2, Topic 1, Video 5, and today we're looking at angles of elevation and depression, a very common context. Okay, so here's a common context, angles of elevation and depression, and here's the diagram I love for it. You ready? This is an eye looking out, because I need to explain this angles of elevation, depression and stuff. So here's a nice horizontal line that sort of goes out towards the horizon. Now if this eye decides to look up, then that is our angle of elevation. And it's all to do with perspective. We're talking about the eye looking up at something up here, whatever that something is. If the eye decides to look down at something, then this, which I call alpha, this is the angle of depression. So they're the difference, but they're very similar, really similar. So I wouldn't worry too much. Now it's looking down at something, and you will be given often a question where you're told the angle of elevation from a person to an aeroplane. That means that the person's the perspective point and they're looking up, or the angle of depression from a person to a boat when they're standing on a cliff. They're looking down at the boat. See, it's all in the language there, but it's also, you need to get the perspective right. Now, of course, this means, and I'll do that little example, where we've got a little person here, and we've got it, oh, I've made a bad choice, haven't I? Let's try this. An aeroplane. I'm pretty proud of that, actually. There's the windows. Got an aeroplane. This little guy here is looking up at the aeroplane. And that means that this is our angle of elevation, but if the aeroplane, or the pilot, was looking down at that person, then there would be an angle of depression. And remember, these are horizontal lines off to the horizon in both directions, which means that they're parallel. So if you go back into your Year 8 work, and you remember the angles between parallel lines, we've got alternate angles. It's a Z angle. So actually the angle of depression and the angle of elevation is equal when the two objects we're talking about, their roles are reversed. As long as it's the same two objects, we get the same, they're equal. So the relationship between them is incredible. Anyway, the types of questions that you'll be asked with things like, let's say this plane, so I'm going to add to this diagram now to do just a simple example and then I'll leave it at that. This plane is, and it's known to be, I don't know what's even reasonable, but it's taking off. So it's 400 metres off the ground, looking down at this person, and we know that the person looking up at the plane can see the angle of elevation is 11 degrees. So then they want to know, well, how far away from the plane am I? If something fell out of the plane, how far away would it fall? And that's where we can do our calculation with a really simple, so we've got 11 degrees, we've got our opposite, and our adjacent is the value we're trying to find, that distance, and so we know we're dealing with tan. So we get tan of 11 is equal to opposite over adjacent, and therefore x is equal to 400 over tan 11. I've just done a double bam, multiplied by x, divided by tan 11, all in one go. Intense stuff. And throw that in the calculator now. 400 divided by tan of 11, and I get 2057.82. So I'll just do the round now, 2057.82, and this is in metres. You might be asked, and make sure you read the question, how many kilometres away to 2 decimal places? So then you would say 2.06 kilometres. That would be kilometres rounded to 2 decimal places. So just be wary of that. Another really common situation is the old building situation. This comes with a little bit more information. So let's start with a simple diagram. Building 1 is 42 metres tall, and building 2 is 76 metres tall. And this person standing on top of building 2 is looking at the top of building 1. What's the angle of depression? That is, what's this angle here? Okay, now usually you can get out with a clinometer, and that measures angles up or angles down. They're really great tools. So usually we know the angle of depression or elevation. We're using it to find a distance, but not always. Who knows? Or actually, so let's say that this is the angle of depression. Let's change the question. This is a bit of a messed up video now. Completely unplanned, would you believe? Let's say that the person standing on top of this building here has actually measured the angle of depression with a clinometer. They've looked down, they've pointed it, they've clicked, and they've measured that angle at 33 degrees. And what we want to know is how far apart are the buildings? How far apart are those buildings? Well, we want to find this. It's going to be the same value. This is a little assumptions here. We've got that assumption again, that it's a right angle because it's perpendicular with the ground. A building should, I would like to think, apart from, of course, the Leaning Tower of Pisa, but even that's pretty close. And we need to find, what's this length? I don't know what that length is. What's this? I don't know that length either. But I do know that this is 42, which leaves me with 34 there. Because 42 from there to here and 34 make my 76. So I can get that information from there and then I can do my calculation. Now sometimes with these contextual problems, it's a good idea to remove the triangle from the main diagram. And just draw it again. X, remember this is 33 and this is 34 and it's in meters and that's my assumed right angle. I've removed the triangle but I still haven't got an angle in the triangle, but this is where we go back to that alternate angles. That's 33 angle of depression, which means we have a 33 angle of elevation from the other side. And now I've got tan, again often tan, opposite, adjacent, so tan 33 is equal to 34 over x, and therefore x is equal to 34 over tan 33, and here we go again on the trusty calculator. 34 divided by tan 33, and would you believe it? Would you believe it? The buildings are 52.36 meters apart. So, that's how we can use angles of elevation and depression to solve some real contextual problems. And just be aware of that role reversal that you can use and make sure you've got nice, clear diagrams. Thanks. Well, that was the joy of angles of elevation and depression. All the best.